All right, so this lesson is really a lot different than we did before. I changed the name of this lesson. What was the name of yesterday's lesson of like this 6-1? Classifying what? Quadrilaterals, right. It was called classifying quadrilaterals. I changed this because we're doing more than just classifying now. We're going to do some stuff. Now, here's the key that we're going to talk about. Okay, the angle sum. Okay, what do you think about in math anyway when you think of the sum, S-U-M? The what? The total when you do what? Add. Right. When you add, right? It's the total after you add things together. All right, so it is a total, you're right, but it's the total after you add things together. All right, and that's what we're going to do today. Okay, but what are we going to add together? The what? The angles. We're going to add angles together. All right, and we're going to add angles of a what? Convex polygon. By the way, let's do this first. I didn't do it till like halfway through the lesson in the last class. But what's the difference between a convex polygon and a convex polygon, or a concave and a convex? Yeah, let's do convex first, okay? So this, I'm just drawing some random polygon. Just see if I extended all these sides, none of these sides would go inside. Remember that? We talked about that a long time ago, didn't we? All right, and then if I extend these, see, none of them go inside here, do they? But what's a convex polygon look like? It's like a cave, good. I said convex, didn't I? Concave polygon, all right? That would be a concave polygon. Why? Because if I extend this side, that's outside the triangle or the figure, right? But watch, if I extend it, look where it does. It goes inside, doesn't it? Same thing with this one. It goes inside. So if I extended it, it goes inside like this, it makes a little cave. See the entrance to the cave? I showed you my cave video, didn't I? Did I show you my video when I walked through the cave? Yeah. No, with my friend, Alex. No, it's not my son. Huh? He came in the other day. He said, because his girlfriend is the assistant coach of the girls' basketball team, so he came in to watch the games and stuff, and he went in, listen to my story. So he came in at the end of the thing, they have like a huddle, they get together, they talk about the game and stuff, and he came in, and the girls are like, oh, you're on Mr. Hamrick's videos. He was almost like a celebrity, right? Like, I know you. You went in the cave with Mr. Hamrick and you did this and all that. And so anyway, I just thought it was kind of funny and he was so happy about that because he's like, it's so good to know that, because he graduated from here. He said, and he went here since he was like in elementary school. He says, it's so cool to come back, even though he doesn't know many people here, but at least people know who he is. You know what I mean? He also helped coach the lacrosse team. Anybody play lacrosse in here? He's at Wilmington University now. So he's an assistant at Wilmington University as a lacrosse coach. Alex Feeney. Real tall guy. Anyway, he sat right in his class, about right where, can't remember, between the two of you. I just remember him sitting there. So anyway, but we're friends now. And we went on that cave video, and that was Alex going through the cave. So this is a cave. So this is what? What? Cave. Yes, I am. There you go. That's all you got to do is ask. All right, so this is a concave. This is convex. We are not going to talk about concave today, except for right now, for this part right here, okay? All these are what? Convex. So everything we do today is about a convex polygon. Everybody with me? All right, so let's do this. Let's start with a triangle. Okay? Now, again, what was the key word that we talked about up here? Not just concave, but angle sum. Right, very good. Angle sum. So what if I asked you, hopefully you're paying attention. I don't think some of you are. This is where we've started now, okay? Everything else was fluff, all right? Wasn't that super important, okay? Now it's important. So let's pay attention. Let's lock on. So this is a triangle. What if I ask you, and this is something we've talked about in the past. This is not a brand new thing. You should know this. What is the angle sum of a triangle? What does that mean? Angle sum. So, okay, good. If this is angle 1, this is angle 2, this is angle 3. So what does that mean? Angle 1 plus angle 2 plus Angle 3, Josiah, say it? 180 degrees. Exactly right. Doesn't matter what kind of triangle we have. Doesn't matter if it's a right angle or right triangle. Doesn't matter if it's an obtuse triangle. No, it doesn't matter. Okay, it doesn't matter if it's equilateral. Doesn't matter if it's isosceles. Any triangle in the world that you can draw, okay, is going to have an angle sum of what? 180 degrees. That's going to be key to what we're going to do here in a minute. Okay, so that's very, very important. That's an angle sum. All right. What about this? What if I had a rectangle? What if I asked you to give me the angle sum of a rectangle? Is it? I thought the angle sum of a triangle was 180. This has an extra angle. Is it going to be the same thing? 190? You just guessing? Let's think about it. If this was a rectangle, what are all four of these angles? 90 degrees. Okay? We learned that a long time ago, right? What is it? 270? Getting closer, but not right. What is the angle sum of a rectangle? Look, how many degrees is this? Thank you. That's 90 degrees, isn't it? How many of these 90-degree angles do we have? We got 4 of them, right? So it's going to be 4 times what? 90. Can you do that in your head? 240? What? Yes. What's 9 times 4? 36. And then stick a 0 on the end because you got that 90. So what's the angle sum of a rectangle? 360. I'm not going to draw it, but what's the angle sum of a square? Why? It's got 4 right angles, just like a rectangle does, doesn't it? Okay. In fact, take a wild guess. I don't expect you to know this, but just take a wild guess. I'm kind of leading you up to something, okay? So it's not a wild guess. It's an educated guess. What about any quadrilateral? Like if I drew any quadrilateral, what do you think the angle sum is of any quadrilateral?
90.
Go with what we're saying, right? If it's a rectangle, that's a 4-sided figure, isn't it? Okay, that's a quadrilateral, 360. A square is a quadrilateral, agreed? 360. So what do you think any quadrilateral might be? 360. And you would be right, okay? Let me show you why. This is what I like about this lesson. There's some lessons that are kind of, and then some lessons I really like. This part right here is part that I really like. I don't know why, I just do. So let's do this. Because we're actually going to come up with our own formula for a, yeah, we could make it like that. We're going to come up with our own formula to find the angle sum of any sided polygon, okay? 4, 5, 6, 7, 17, 20, 100, 1,000. No matter how many sides that you have, I can find the angle sum of that polygon. And so will you after we're done with this, all right? See, aren't you excited now? You find the angle sum of any polygon? Yeah, I think it's kind of cool. So what I'm going to do is this. I'm going to do it to this. We're going to do it to 2 other ones. And I want you to start thinking of a pattern that's developing, okay? I want you to look for a pattern. So first thing I'm going to do, let's change color first, is I'm going to draw a diagonal. We've talked about a diagonal, but I'm going to pick just one particular point. I don't care what point. It could have been this one, this one, this one. I'm just going to pick this one, right? And I want to draw a diagonal. What is a diagonal? It goes from one point, not just to another, but to a non-consecutive vertex, which means not to this one, because that's right on the polygon. Not to this one. That's right on the polygon. Which one am I going to draw to? This one all the way across. That would be a diagonal. Okay? Everybody with me? Why did I do that? I did that because I split this quadrilateral into what? Well, it's not necessarily in half, but into 2 triangles. Very good. Into 2 triangles. I'll put a 1 there. See what the 1 represents? See this whole triangle right here? That's triangle 1. What am I going to make here? 2. This is triangle 2. You with me? All right. So what is the sum of the angles of triangle 1? 180. Right, because any triangle, the sum of the angles is 180. Agreed? What about the sum of the angles of triangle 2? That's also 180. So all four of the angles of the quadrilateral are going to be what? This is 180, that's 180. What do all these angles, all four of these angles add up to be? 360 degrees. It was a quadrilateral originally, right. And I drew this diagonal and I turned it into two what? Triangles. So watch. If I have two triangles, what do? It's 2 times what? 180. Because each triangle is 180, right? 2 triangles would be 2 times 180. What if I had 3 triangles? It'd be what? 3 times 180. What if I had 10 triangles? 10 times 180. You with me? Okay. Again, we're going to establish a pattern. Here's what I'm going to do. Write this down. 4 sides. How many triangles did I get when I drew that diagonal? How many triangles did I get? Look at it. I got 2 of them. I got 2 triangles. Okay? You see that? 4 sides, 2 triangles. And then I go what? 2 times 180, and that gives me 360. So this is what we're going to concentrate on right there. All right? Now, that's not enough to see a pattern. You can't just have one thing and establish a pattern from one thing, right? Maybe after the second one, we're going to do like 2 more, okay? So we're going to do 3 altogether, and I want us to establish a pattern. So write this like maybe off to the side, okay, not with all the pictures and stuff, but keep a list of these 3 things, all right? 4 sides, 2 triangles, 2 times 180. Everybody got that? Okay. So now I did 4 sides, a quadrilateral. What do you think my next one's going to be? Let's go 5 sides, okay? Now watch. I'm just going to draw just any random 5-sided polygon. There's 1, 2, there's 3. I'm not trying to make it any kind of a special polygon. I'm just making 5 sides. Is that 5 sides? Yep, 1, 2, 3, 4, 5. 5 sides. Now, what did I do on that quadrilateral? Did it in red. What did I do? Yeah, but I drew a what? What was the word? It starts with D, diagonals. I can choose any point that I want, okay, but I'm just going to choose one. Let's choose this point down here. Doesn't make any difference, okay? What I'm going to do is draw a diagonal from that one particular point, okay? You with me? So do I go to here? No. Where do I go? Up to there, and then I go where else? From that same point, do I go to there? Go to there. All right. So there's my diagonals. What do I care about? I care about how many what? What did I divide this into? 3 what? Triangles, right? So there's 1 triangle. There's a second triangle. Do you see the triangles right here? That one in the middle. Then you got that third one. See this one right here? Then you got that first one is this one right here. So I got 3 triangles. So let's write down what I had. How many sides did I have here? 5 sides. How many triangles do I have now? 3 triangles. Now, we might have enough to establish a pattern. I'm going to do 1 more, okay? But what do you think the pattern might be? If I have a certain number of sides, I had 4 sides before and 2 triangles. I got 5 sides and 3 triangles.
So you got 6 sides, you have 4 triangles.
There you go. You got it. You found the pattern, okay? And we're going to do that, but I just want you to thinking about it. So now, excuse me, how do I find the angle sum? I take 3 times what? 180, right? Because this triangle has 180, that triangle's got 180, that triangle's got 180, correct? So 3 of them is 3 times 180, and I think that's 540. Okay? What does that mean, 540? Does that mean each angle is 540? No, it means this angle plus this one, plus this one, plus this one, plus this one. They're not all equal. I know I just put 1 arc for each of them. That usually means they're all equal. But what it means is all 5 of those angles add up to be what? 540 degrees. We good? Okay, let's do 1 more, and then we'll definitely have our pattern down at this point. So now, I did 5 sides. What am I going to do now? Let's go 6. Okay, so there's 1, there's 2, there's 3, there's 4, there's 5, and then there's 6. Again, this is not any kind of like special let me make these attach. It's not any kind of special. It's just a random, I just drew random sides, okay? And they all attach. Well, that one kind of does. Yeah, you get the idea. Okay? So now, what are we going to do? Draw some what? Yeah, pick any point. I don't care what point you pick. Which one do you want to pick? Bottom right one, this one? All right, so we'll pick that one. Doesn't matter. Let's draw all the diagonals. Do we go to there? No, but we will go to this. Okay? And then we're going to go to there. And then we're going to go to there. Agreed? All right. How many triangles do we have? 1, 2, 3, 4. So let's do that thing again. How many sides do I have? 6 sides. Now how many triangles do I have? 4. Does it fit what we thought the pattern might be? Absolutely. I could do this over and over again. It's always going to fit every single time. So I have 4 triangles. Yes? So that means what? How do I find the angle sum? 4 times what? 180. And that's 720. So all 6 of these angles, see that angle right there? 2, 3, 4, 5, 6. All 6 of those angles add up to be 720 degrees. Okay. It goes, well, the triangles go down by 2, right? So let's pick some other random number of sides. Give me 27. That's fine. Okay. So if I have, not that big of a deal. What did you say? 7? Did you say 27? Yeah. So 27. All right. Let's say you had 27 sides, and I wanted to find the angle sum of a figure that's got 27 sides. We won't see that very often, but who knows? All right. So how many triangles are we going to have? 25 triangles. Okay. So how do I find the angle sum? What math do I do? 25 times what? 180. Whatever that is. I have no idea what that is. You can find that on a calculator. And let's, I got a calculator right here. Is that what it is? I think it's going to be higher than that. 180 times 25 is 4,500. Okay? 4,500 degrees. If I had a 27-sided figure, okay, all the angles would add up to 4,500 degrees. All right? You with me? Now, I think we have enough information to figure out a formula for this. All right? You kind of know what it is already in your head, but let's write it down kind of formally. Let's use n to represent how many sides we have. Remember we had 3 sides, 4 sides, 5 sides, 6 sides? Okay, n represents what? How many sides you have. Okay? So if I know how many sides I have, how many triangles am I going to have? So if I have n number of sides, how many triangles am I going to have? 2 less. Right, so write it down. What is it? N what? Minus 2. So that's how many triangles we're going to have. I get some confused looks. If I had 27 sides, how many triangles did I have? 25. Why? 27 minus 2. 6 sides, how many triangles? 4. So it's 6 what? Minus 4. You got it? 5 sides is 5 what? Minus 2, which is 3. Okay? 4 sides, 4 minus 2. Do you see the pattern? So let's scroll all the way back to here. So if I had n number of sides, which could represent any number, how many triangles am I going to have? N minus 2. Now, how do I find the angle sum, though? So that's how many triangles I have. What did I always do with the number of triangles? Times it by 180. That's right. Times it by 180. So that, I'll put it equals. This is the angle sum. And look at that. You came up with the formula, didn't you? Well, a little help from me. But you see where it comes from, though, don't you? So it's, I mean, I could have sat here very first thing and said, okay, n is how many sides, take away 2 times 180, that's your angle sum, boom, I'm done. But you wouldn't have the appreciation for it, would you? All right, you're like, well, where'd that come from? Why'd you minus 2 from it? Now we know why we minus 2 from it, yeah? Okay, so that's how you find the angle sum. So let's do an octagon. So here's a kind of problem that would be on a quiz or a test and your homeworks, okay? It'll say, find the angle, or the sum. It'll say this. It'll say the sum of the angles of a what? Or an octagon. All right? So that's what a problem on a quiz or a test could tell you to do. So first of all, I heard it. Raheem, what is it? 8. Octagon is 8 sides. So look, we're going to use this little formula right here. So if I want to find the angle sum, is what you're trying to do, right? Sum of the angles, angle sum. I want to do what? Take 8 minus 2, and then multiply it by 180. 8 minus 2 is 6 times 180. I think that's 1080. I just did it in the last class. How do I not remember it? It's 1080. I was right. So it's 1080. 1080 degrees. And there you go. That's the angle sum. What does it mean? It means if I had an octagon, what do you probably see every single day that's an octagon? A stop sign, okay? If I took a protractor, all right, don't do this, all right, especially if you're in a car. If I measured if I measured all the angles of that stop sign, what would they all add up to be? 1080, 1080. Everybody see that? All right. So that's what it would be. Now, with that said, let's go back to the stop sign. All right. We just did a stop sign, or we just did an octagon. So let me do this. Let me make this 8 sides. Now, this is not just any old random octagon. All those other ones I drew earlier are just random polygons, okay? Let's take a look at this. What do you think might be special about this octagon? What distance? Okay, so the length of the sides, is that what you're saying? The distance from here to here? Absolutely, look at it. Look at that length. Look at that one, all the way around. What do you think it looks like, just to your eyes? What do you think it looks like? It looks like they're all what? They're congruent. Good, it's a good geometry word. Equal or congruent, okay? And that's what we're going to do. We're going to mark them all equal. Now, if all the sides are equal, what do you think? Well, this isn't necessarily always true, but what also do you think might be true about the angles? Look at that angle and that angle. They all look exactly the same, don't they? So they are all equal. We give this polygon a special name. Now, it's an octagon, okay? But we call this a regular octagon. What do you think the regular, it means what? All the sides are equal and all the angles are equal, all right? So regular octagon means you have equal sides and you have equal angles. Good. Everybody with me? All right. Now, we're going back to what we just did earlier. What did we say they all add up to be? Right, 1080. Excuse me. So the angle sum, I'll write it right here. The angle sum is equal to 1080. All right. I used this example for the last class. I don't know if it helped them or not, but I'm going to try it again with you guys, okay? So everybody listen. What if I took 8 of you, the 8 that are not sleeping, okay? So the 8 without their heads on the desk. Is that how many you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we got 11. Wow, 11 paying attention. That's good. But let's say there's 8 of you, all right? And I'm playing favorites. I'm taking my favorite 8. Actually, you're all my favorite. So, okay. All right. Okay. So, I don't know where that came from. All right, so here we go. If I had $1,080, I don't know why I have 1,000. I don't, believe me. If I had $1,080, listen, and I wanted to distribute that evenly between 8 of you, how would you know how much each person gets? Subtracting it? Dividing by what? So if I had $1,080, and I wanted to distribute it evenly between 8 of you, what would I do? I would divide by 8, wouldn't I? Okay? Now, I don't have $1,080. We're not talking dollars. What are we talking? Degrees. Okay, we're talking degrees. So all of these angles add up to 1080. All these angles, all 8 of them, are exactly the same. Okay, distributing evenly. So how do I find each angle? Okay, how do I find that angle and that one and so forth? Just find them and all of them are going to be the same. Exactly right. So what do? I just divide, right? Use calculator. 1080 divided by 8, I believe, is 135. Okay, so that means each angle is how much? Is 135 degrees. Every single angle in here is 135. Okay, now this little formula, this little thing right here, taking that 1080 and dividing it by 8, only works with what? Well, I shouldn't say octagon. Regular polygon, right, any-sided figure, okay? But it has to be regular. What does it mean to be regular? All the sides are equal and all the angles are equal, okay? You can't do this with this one right here, okay? Because look at that angle. That's different than this one. It's different than that. It's different than that. You see it? All right, so you can only do it when you have a regular octagon. We good? All right, I got 5 more minutes. I got one more thing to talk about. Let's talk about this. I'm going to go back to a triangle, and I'm going to make a specific type of triangle just to show you. All right. Now, the first thing we're going to do, we've talked about before. Here's a regular triangle. Now, let's pay attention. This is a regular triangle, so all 3 sides are equal. What do I know about an equilateral triangle? It's also what? Angular. Okay? So, how many degrees is each of these angles? 60 degrees. Good. I'm just doing this because the math is easy. All right? I could use any triangle with any amount of degrees. I just picked this one just because it's easier. Now, watch very carefully. What if I extended this side right there? And I took this side and I extended it, I'm trying to make that even, and extended that here. These angles that are inside the triangle, what do you think they're called? Interior angles. Very good. We've discussed that before. Okay? So what do you think? Oh, that one looks a little crooked. That one's supposed to go straight. Okay? Everybody with me? It's a little crooked, but it's supposed to go straight. How many degrees? Well, first of all, what do I call this angle? If this is interior, this one's what? Exterior. Okay? So how many degrees do you think that is? Right, 180 minus 60, very good, which is 120. So what's this going to be? That's 120. And what's this one going to be? 120. Now, here's the thing. Don't pack up. I see some of you packing up. This is super important right here. And it's super easy, but you got to listen to it. Okay, if you're asleep like those guys, you're not going to understand this. So watch. What I'm going to do is I want to find the sum, because earlier we found the sum of the interior angles, okay? This time, I want to find the sum of the, what do you think? Exterior angles. Now, is it going to be this, exterior angles. Is it going to be the same as the sum of the interior? No, because that's 60, 60, 60, that's 180. That's already 120 and 120, that's 240. It's already different, isn't it? So I got 120, 120, and 120. What's that give me? 360. So the sum of the exterior angles on this is 360. Watch this. If I had more time, I'd go a little bit further with this, but this is good enough. If this is a rectangle, what's true about all of these? All right angles. So I'm just going to, I don't have much time. Oops. Yeah, I guess I could do it like this. Watch. Extend it here. Extend that one. Extend this one. Extend this one. Okay? You with me? So if this is 90, what's this? That's 90. I'll just put a 90 here instead of a box. Is that all right? If that's 90, what's this one? 90. What? 90. What? 90. Okay? What's the sum of the exterior angles on this one? it's still 360. Okay? So I could keep going. I don't have enough time. I could keep going, but you're going to look at it. You're going to find out that the exterior angles of any polygon, it doesn't matter how many sides you have, of any polygon is always going to be what? 360 degrees. Okay? I could have a 10-sided figure, and if I add up all the exterior angles, they're still going to add up to what? To 360. So that's really, really important. It's so important, I'm going to put it in a box. All right? So it doesn't matter how many sides you have. The exterior angles will always add up to 360. Doesn't matter if it's 3 sides, 4 sides, 5 sides, 6 sides. Does not matter. It's always going to be 360. That's kind of interesting, isn't it? There's more that I could show you on that, which is kind of interesting, but we're out of time. So let's put the homework down. So it's 6.1b. Now, this is a little different. Listen to me. Hey, I have not finished. Maddie, up here. Guys. So this is a little different because I changed yesterday's. Remember, I was supposed to go 1 to 18, but I only went 1 to what? 13. So this one's going to start at 14 and go to 34. Okay? It was 18 to 30 or 19 to 34, but it's 14 to 34 now. So just look at section 6.1. You'll see the problems. Okay? All right, that's it. Have that done for tomorrow.